Welcome in the second section of our course. In the second section, we'll be looking at the immutable design of Apache Spark. So firstly, we'll delve into Spark RDD parent-child chain. We'll try to implement our own RDD that inherit the parent properties. Next, we'll be using RDD in an immutable way. We'll be using data frame operations to transform data frame and add additional column to it. Next, we'll see how immutability helps us in the high concurrent environment. At the end, we'll be using dataset API in an immutable way. And welcome in the first video. In this video, we'll be delving into Spark RDD's parent-child chain. We'll start from extending RDD, then we're chaining new RDD with the parent one, and we'll be testing our custom RDD accordingly. So this is our simple test. Test is simple, but it hides a lot of complexity. But let's start from creating a list of record. Record is just a case class that has an amount and description. So amount 1 and D1 description. Then we are creating multiple RDD, passing RDD to it, and multiplier equal to 10. So this is a first thing that hides a lot of complexity. So we are passing an RDD that is a parent RDD because it has data that was loaded to the another RDD. This way we will build the inheritance chain of two RDDs. So let's create multiple RDD class. In that class, we have two things that are passing that as parameters. First is a prev RDD of record and multiplier that is a double. Why is it called previous and not parent? Because there could be chain of multiple RDDs. So inside of our RDD, there could be another one and so on and so on. So this is not always the parent of whole direct acyclic graph. But next we are just extending RDD of type record. So this is our type, and we need to pass the RDD that is extended. RDD has a lot of methods, so we can override whichever method we want. But this time we are going with a compute method. So we are overriding the compute method to calculate multiplier. We are getting a partition, split, and task context. Those are two things that are passed by the Spark execution engine to our method, so we don't need to worry about it. But the thing is that we need to worry is that we need to return the iterator of exactly the same type as the type that we pass to the RDD class in the inheritance chain. So this will be an iterator of record. Next, all logic is happening. We are executing the first parent logic. First parent is just taking the first RDD in our chain, and this type is record. We are taking an iterator of split and context. Split is just a partition that will be executed. We know that the Spark RDD is partitioned by the partitioner, but here we are just getting the specific partition that we need to split off. So iterator is taking the partition and task context. That's why it knows which values should be returned from that iterator method. Next, for every record in that iterator, that is a sales record, so this is our amount and description, we are multiplying amount by the multiplier that was passed to the constructor here. So this is our double. This way, we have a mult that is a multiplied amount by the multiplier. And we can then return new record that has new amount. Amount of the old record multiplied by our multiplier and description of the sales record. Second thing that also we need to override is get partition. So we want to keep the partitioning of the parent RDD. So if the previous RDD here will have 100 partitions, let's say, we also want our multiple RDD to have also 100 partitions. So we want to retain that information about partitions. We don't want to lose that information somehow. That's why we are just proxying it to the first parent. And first parent of the RDD will just take the previous and partitions from that specific RDD. This way we created new multiplied RDD, we passed the parent and multiplier. Then our extended RDD, we need to collect it and call to list. And our list should have 10 and the 1. 10 because we multiplied 1 by 10. And someone may ask why we didn't execute compute method. Compute was executed automatically when we created new RDD. So this is always executed without the explicit method call. So let's start this test and see if this created our RDD indeed. We can see that test passed, so it means that we're able to extend our parent RDD and add behavior to that our RDD.